Hello, everyone. So in this problem, I'm going to do the one-way ANOVA by hand. So a psychologist is studying the effects of dream deprivation on a person's anxiety levels during waking hours. So in this study, 3 groups of subjects were randomly chosen from a large group of college students who wanted to participate in this study. So group 1 had their sleep interrupted 4 times each night. Group 2 subjects had their sleep interrupted 4 times also, but only on 2 occasions they were wakened at the onset of the dream. Group 3 also were wakened 4 times, each time at the onset of a dream. Now, this procedure was repeated 10 times. And each day, all subjects were given a test to determine their levels of anxiety. So the table below records the total number of test scores for each person over the entire project. Higher totals means higher anxiety levels. Now, you can take time and then read through this. Now, let's go to the table. So in group 1, we have 6 subjects. And group 2, we have 7. And then group 3, we have 5 subjects. So we have 3 groups here. And these are the scores. So X1 here are the scores for group 1. And then X1 squared. So each of these are squared. And remember, from what we have gone over in class, you need these for your sum of squares, or SS, okay, to calculate your SS values. And that's very important to remember. So it is the same for group 2. You have your X2, these are the scores, and then when you square them, these are your scores. So here it's just trying to make things a little simpler for us so that we could easily add them, okay? So X squared and then X squared and X, like that. All right. So first of all, we have to set up our hypothesis. So our hypothesis is going to be for HO, we have mu1 equals mu2 equals mu3. And then our HA or H1, at least 2 of the means are not equal. Or at least one of the means is different. Remember, we talked about this as well. So that is going to be our hypothesis. Now, because we are dealing with variances, we've got to go to the SS, the sum of squares, total, right? So we've got to remember the formula for the sum of squares total. And if you can remember, dealing with the sum of squares total, you have to remember the formula for variance, the computation formula. And that's exactly what we are going to be using. So we're going to have the sum of squares total is going to give us, so SS total is going to give us the summation of X squared total minus summation of X total squared over N. And the N here, you could also say a total N. So we're dealing with a total N and not a small group N. So first of all, probably we could start with our N value. Our N value is going to be, so we go to each of these groups. We've got 6 here, 7, and then 5. So that gives us a total of 18. 6 plus 7 plus 5. That is 18. So n is 18. Now, we're going to find this next. The summation of x squared total. So I'm going to add, these are my x squared for group 1 plus, so add all of them, add all of these, and then add all of that. So we're going to add all 3 together. In other words, we're going to do summation of x squared total is going to be summation of x squared for group 1 plus summation of x squared for group 2 plus summation of x squared for group 3. So add all of them together. So 81 plus 49, let me put that in a calculator and see what I'm going to get. So 81 plus 49 plus 9 plus 36 plus 25 plus 64. You could pause the video and then do it by yourself and see what you're going to get. All right, so I'm going to have let me do it here. The summation of x squared 1 is going to give me 264. The summation of x squared 2, group 2, is going to give me 551. The summation of x squared for group 3 is going to give me 671. So add the 3 together, and then I'm getting, add all the 3 together, and I'm going to get, let's see, 1,400, 486. 1,486. 1,486. So that is this plus that, and then plus that. And then you're adding all of these together as well. Now let's go to the summation of x total. And then after I put a square on it. So here I'm adding all the x's. So add all the x for group 1, add all the x for group 2, add all the x for group 3, add all of them together, and then see what you're going to get. So with that, I'm going to have 9 plus 7 plus 3 plus 6 plus 5 plus 8 plus, and then I keep going. You don't have to, you could keep going. You don't have to maybe do for x1, x2, x3. I mean, you might need that for some of the other stuff we're going to calculate for. That's why you want to break them down, break them up like that. But you could do it together. Add all of them, group 1, group 2, group 3. And here, remember, we are doing just the x, just the x. So for the x's for group 1, that is 9 plus 7 plus 3 plus 6 plus 5 plus 8. That should give me 38. And we do the same thing for group 2. We're doing 10 plus 9 plus 11 plus 10 plus 7 plus 6 plus 8. And that gives me 61. And then group 3, 15 plus 11 plus 12 plus 9 plus 10, that gives me 57, which is 156. 156. 156. So this is what I'm going to have now. This is what I'm going to have now. So from my formula, SStot, I'm going to have SStot equals, so this guy here, the x squared, is going to be 1,486 minus the summation of x, I got, I forgot the value. Is it 156? 156, yes. 156. 156, let me put that in here. 156 squared, remember there is a square, divided by 18. So 156 squared divided by 18. 156 squared divided by 18. 156 squared divided by 18, that gives me 1,352. 1,352. So I'm going to have, just because of the calculator we use, that's why I'm doing it backwards. Okay, 52. But if you have a good calculator, you could do it that way. 1,486 minus, and then you do that. So 1,486 minus that will give me 134. So my sum of squares total is 134. 134. Now, remember that the sum of squares total gives us the sum of squares between the groups, and then sum of squares within the groups. So you are going to have variability between the groups, and then also variability within each single group. And that gives you the total. So to write that out, this 134 number is giving me, sum of squares total should give me, oops, 1 second. My sum of squares total, which is 134, is equal to sum of squares between the groups plus sum of squares within the groups. And remember, this is treatment. And in the table, you're going to see that. And this is error, like that. So sum of squares between the groups, sum of squares within the groups, within the groups. All right. Now, I know that my SS total is 134. But what about the sum of squares between the groups and sum of squares within the groups? Now, for the formula for finding sum of squares between the groups, because if I get one of those, I could subtract from 134, which is my excess total, and then get the other one. So if I have SSbet, I could subtract that number from 134, or the SS total, to get SSW. But I want to show you the formulas for both. So SS between the groups. This is between the groups. So this is what we're going to have for the formula. So we have SS between the groups. Let me put that here. Oops. Okay. I'm going to erase almost everything. And then I'm going to start with SS between the groups. So the formula for SS between the groups is that we're going to have a summation of x1, summation of just the x1, and then you square it, divide by the n1. So like that. Summation, oops, x1 squared divided by n1 plus, you do the same thing for group 2, squared divided by n2 plus summation of x3 squared over n3 minus, so you add all of these and then minus, you're going to do summation of x total squared divided by the total n. So write this down. So minus summation of x total, and then you put a square on it, divided by the big N, divided by the big N. And if you remember, this value here, this thing here, we had it in the formula for SS total. It was in the formula for SS total. So you might already have that value. And that was 1,352. 1,352. I think that was it. Yep, 1,352. Okay, but we have to find these three guys. So this is summation of x1, and we did that too. Summation of x1, we got 36. So you put a square on that. Summation of x1, remember this is just add all the x's and put a square on it. So SSbet, for the first one, we're going to have 36 squared over n1, which is 6, plus. For summation of the x2, that is adding all the x2 together, I think we got, let's see, I think I had it. We got 61. 61. So you're going to have 61 squared over, and we have 7 for n2. And then the third one, if you add all of them, we have 57 divided by, we've got 5 of those, minus this guy here is 1,352. Now we have to work this out. So 36 squared divided by 6. 36 squared is 1,296 divided by 6. I have 216. 61 squared divided by 7. I have 531.571 plus 57 squared divided by 5. That gives me 649. 649.8. 649.8. 649.8. 649.8. 649.8. And then all these, after you add them, you subtract 1,352 from it. 1,352. So let's add all of them together. 631.571 plus 216. We've got 1,397.371 minus 1,352. And this should give me 45.371. So my SSbet between the groups is 45.371. 45.371. So if I have SS total, which was 134, remember we calculated it to be 134. So SS total is 134 equals 45.371 plus SSW. So I could find my SSW by subtracting 45.371 from 134. I could do that. Let me double check on my values again if I got them right. Well. I think I did something wrong. Let me do it again. So 38 squared. 38 squared divided by 6. Oh yeah, That was the problem. 38 squared divided by 6. That should give me 240.667. So this one was wrong because I knew that my value wasn't right. 240.667. 667. It's 38, not 36. Oh, okay. 38, 38, 38. All right, so let me add those together again. Plus 531.571 plus 649.8. Okay, so that gives me 1,400. 1,422. 22.037 or 038. So if I do the subtraction, I'm going to have 1,422.038 minus 1,352. That gives me 70.038. So that should be my value here. 70.038. Okay. Like that. So if I subtract 70.038 from 134, I'm going to get SSW is also 63.962. So I've got my SSW as well. But again, is there a formula to find SS within the groups? Yes, there is a formula to do that as well. I'm going to show you that formula. Now, for that formula, because SSW is sum of squares or variability within the group, that should look very familiar to us. That will just be the top of a variance formula. Remember when you're finding the variance or standard deviation using the computational formula, because you're doing each group separately and then add all of them together. So that formula will be very familiar to us. And that should be, so SSW, and I'm not going to go through that. I'm just going to show you the formula. So for SSW, this is what we're going to have. And remember, you could find SSW, subtract from SS total to get SSBET, all right? Okay. So SSW is going to be, SSW is going to be SS, or probably, yeah, let me just skip the SS1, SS2, SSW1 plus SSW2, SSW3, like that. So SSW1 is going to be summation, okay. Do it again. SSW is, so SSW1, let me just take my time, SSW2 plus SSW3. SSW1 is going to be summation of x squared for group 1 minus summation of x1 all squared all over n1, like that. You see that? And then SSW2, so same thing, only that you're doing it for group 2 minus SS2 squared over n2. SS3, same thing. W3 summation S33 minus summation of x3 all squared over n3, like that. So if I'm dealing with SSW1, I go to the x squared, which are going to be these values. I already have the squared here. If you don't have them, you find them. Add all of them together, right? And that's the summation of the x squared one. And we did that when we were trying to find SS total. And then minus summation of x1. So add all the x1 together and then put a square on the total divided by n1, which is 6. Okay? And when you do that for SSW1, you should get SSW1, you should get 23.333. When you do the same thing, I mean, not the same thing, but when you go to group 2 and then follow the same steps, you're going to get 19.429. For group 3, you're going to get 21.2. And that should add up to 63.962, which you already got, right? Which you already got from the top. So that is it. Now, after that, we want to find our variance estimates. Our variance estimates. And sometimes that is also called the mean squares. The mean squares. Now, to do that, we're going to need degrees of freedom to do that. We're going to need degrees of freedom to do that. And remember, we're doing between the groups and then within the groups. So for mean squares or MS or variance estimates for between the groups, how do we get that? So you're going to use your SSbet, SSbet, SSbet. So mean squares or MS or variance estimates, MSbet. That is SSbet over degrees of freedom for BET. Now, sometimes degrees of freedom for BET, is going to say degrees of freedom for N, or the numerator, the top, or degrees of freedom for the treatment. So degrees of freedom, we already know SSbet. Degrees of freedom for BET is going to be the number of groups. We have K number of groups minus 1. K number of groups minus 1. And here we have 3 groups. So 3 minus 1 is 2. And that's it. So MSbet is going to be our SSbet, which was 70.038 divided by 2, which should give us 35.014. And then for MSW, we're going to have SSW over DFW. And DFW is DF denominator. To find that DF denominator, it's going to be N, the big N, minus your K. Now, the big N is 6 plus 7, all the number of data values you have, which is 18, minus 3, which gives us 15. So our SSW was, what was the value? Let me check again from my calculator. That was 63.962 divided by 15. 63.962, 63.962 divided by 15. And that should give us 4.264. So these are MS or mean squares or variance estimates. Now, what do you do with the variance estimate? Remember, with all these, we are trying to get to F statistic or F ratio. And then when we find that, we find a p-value and make a conclusion. So Our F ratio or F statistic is going to be the MS, the mean squared BET divided by the mean squared W. That's why we did all these. So the variance estimates between the groups divided by the variance estimates within the groups. That's all we wanted to do to get our F ratio, what is called the F ratio. And then we use the F table. That is if you're doing this manually, okay? So now to find our F ratio or F statistic, we're going to have MS numerator over MS denominator. So F equals MS BET over MSW. Now, MSBET was, I think, 35.014, and then MSW is 4.264. And this should give us, let's see, divided by 4.264, and that is going to give us 8.212 for our F. So our F ratio or F statistic is going to be 8.212. 8.212. Okay? 8.212. Now, how do we get our p-value? That is the next thing we're going to do. How do we get our p-value? To find our p-value, we are going to be using the F table. We're going to be using the F table. Now, the F table, if you go to Appendix 2, where you have all the stats tables, you're going to find it. And I'm going to attach it to this video in Canvas so that you could also go in and then find it. So let me quickly show you how it looks like and how to use it. So the F table, so these are the tables. And I'm going to scroll down. This is going to be, the F table is going to be table 8. So this is table 5, the Z table. That's not what I need for now. Yep. So this is table 8. So if you look at table 8, so this, for F, you're always looking at a right tail, okay? A right tail area. So my F statistic is 8.212. 8.212. I'm looking at this area on the right. So here we have degrees of freedom D, which is the denominator, which is W within the group. So degrees of freedom within the groups. And then up top, you have degrees of freedom N, which is between the groups. Now, from our example, degrees of freedom between the groups was 2. Degrees of freedom within the groups was 15. So I've got to scroll down to 15. Degrees of freedom 15. Where is it? Yep, there we go. So I've got 2 for degrees of freedom N, or between the groups on top. And then I'm going to scroll down to 15. So 15 is going to be here. Now, my F statistic or my F ratio was 8.212. So with 2 and then 15, I'm looking at these areas, 2 and then 15. But my F is going to be between, right here, between 6.36 and 11.34. And then I'm going to check here for my p-values. So my p is going to be between 0.001, and then 0.01. So that's my P. That's my P value. Okay. And here in the problem, you are given a significance level. Alpha is 0.05. So you make the conclusion. If my P value is less than alpha, I reject the null hypothesis. If my P value is greater than alpha, I fail to reject the null hypothesis. And that's it. And that's the conclusion. Okay. All right. So thank you so much. I'm going to use SStot to show you how to get all these values so that you don't go through all these calculations as much as possible. But it's good you do them so that at least you know how to do them manually, even with the table as well. Thank you. Bye.